So for now number 8, we want to write the equation of a line going through the points 2, 3, and negative 1, 5. It doesn't tell us whether we need to use our slope-intercept form or our point-slope form. Again, if you're given 2 points, it's always easier to use point-slope form. Okay, and again, the name of that tells you the 2 things that you need. You need a point and you need the slope. So I have 2 points, so I have part of that already. So I'm going to have to find the slope before I can even talk about what point slope form is again. So let's do the slope formula. Again, that's y1 minus y2 over x1 minus x2. And again, I'll label the first ordered pair x1, y1, and the second one x2, y2. So y1 is 3. You have a minus sign from the formula, and y2 is 5. So I'm going to have 3 minus 5 on the top. And on the bottom, x1 is 2. Again, a minus sign from the formula, and x1 is negative 1. So on the bottom, I'm going to have 2 minus negative 1. So on the top, 3 minus 5, total opposite. 3 minus 5 is going to be a negative 2. And on the bottom, keep change, add the opposite. However you want to look at it, it should give you a positive 3. So the slope of your line is going to be negative 2 over 3. So again, point slope form is y minus y1 equals m times x minus x1. Again, you always want regular old x and regular old y in the equation. So I'm keeping this y and I'm keeping this x. It's everything else that I'm replacing. Since I have x1 and y1 in my formula, and this is already labeled x1, y1, I'm going to use 2, 3 as the point that I'm plugging in, and I'm going to ignore my second coordinate there. So I'm going to have y minus, again, coming down from that formula, and y1 is 3, equals m we found over on the left. That's negative 2/3. And again, I'll bring down that x and the minus sign from the formula, and x1 is 2. So in point slope form, it's y minus 3 equals negative 2/3 times x minus 2. So for section 2.8, we're going to talk about slopes of parallel and perpendicular lines. So we're going to basically still be working with the equations of the lines that we were working with in 2.7. So we're going to talk again about point slope form and slope intercept form. But now we're going to also bring in parallel lines and perpendicular lines. Okay, so again, we've talked about this a number of times so far already this year. Parallel lines are 2 lines that are never intersect. Okay, and the thing that's special about parallel lines is that they have the same slope or they have equal slopes. So if you look at the picture over on the left, I drew 2 lines and then I just wrote what the equations were. So in the first line on the bottom here, again, you can see that the slope of that line there is 2. And when I graph this other line that's above it, and again, if I look at that, that slope is also 2. So those are 2 parallel lines, same exact slope. The y-intercept doesn't matter. Notice this has a y-intercept of negative 2, and that one's a positive 1. Doesn't matter. They're parallel because they have the same slope. That's it. Okay, and then underneath that, it says, should parallel lines have the same y-intercept, and why? Okay, should they have the same y-intercept? The answer there is going to be no. Okay, because if they did, if you look again right up at that top graph that we were just looking at, if I slide that negative 2 up to a positive 1, what's going to happen is you're going to be graphing the same exact line. So you wouldn't have parallel lines, you would have the same lines. So no, because you'd have the same line. Okay, you wouldn't have 2 distinct lines, it would just be 1 line. Okay, perpendicular lines, again, we've also spoken about this definition a bunch of times. Perpendicular lines are lines that intersect to form right angles, and again, you have your symbol for perpendicular here, that big upside down T. Okay, and the thing that's going to be special about perpendicular lines is that they have negative reciprocal slopes. So what that means is they're going to be the flip of each other, and one has to be negative and one has to be positive. So if you look at the example over on the left here, the slope of that top line is negative 3 over 2, and the bottom line is 2 over 3. So again, if I have negative 3 over 2, and I want the negative reciprocal of that, again, if we flip that, then and negate it, it's going to become positive, and then the 3 is going to go on the bottom and the 2 is going to go on the top. So that's how you get those 2 slopes there. One has to be negative, one has to be positive, okay? And they're the flip of each other. And just keep in mind, if you were going to flip 2, and 2 isn't a fraction to begin with, stick it over 1. Then when I flip that, it'll become 1 over 2. And again, negative 1 over 2 would be its negative reciprocal. So what is the product of the slopes of perpendicular lines? Again, if I just take a look, I'll use the negative 3 over 2 and the 2 over 3. If you were to multiply, product means multiply. If you were to multiply those two things together, remember when you multiply fractions, you multiply straight across. Okay, you're going to end up with negative 3 times 2, which is going to be negative 6. And on the bottom, you're going to have 2 times 3, which is going to be a positive 6. And negative 6 divided by positive 6 is going to be a negative 1. Okay, no matter what, again, if you multiply these two numbers together, you're always going to get a negative 1. Okay, and then the other question on the bottom here is, could perpendicular lines share the same y-intercept? And the answer there is going to be yes, they can. If you just look back up at this picture right here for 1 second, let me change my color so we can stand out a little bit. Okay, if I were to ignore where the xy axis was right now and I were to draw a new one, let's say this became my y-axis and I'll keep the x-axis where it was. Both those lines cross the y-axis right at that point. So can they have the same y-intercept? Yes, they can. It doesn't matter for perpendicular lines. Okay, so for example number 1, we have, are the lines M1 and M2 parallel, and explain. Okay, so if they're going to be parallel, they have to have the same slope. And since I have the graphs, instead of using the slope formula, I'm going to count. So for my first one, I'll do this bottom line. I'll highlight my 2 points in red here. Again, we're going to count. Doesn't matter which point you start at, but again, please make sure that you're moving up or down first. So I'm going to go down here and then to the right. So now let's count. I have to move down 1, 2, 3, 4, 5. As you go down, y is negative, so that's going to be a negative 5. And then I have to go to the right, 1, 2. As you go to the right, x's are positive, so that's going to be a positive 2. So the slope of line 1 is negative 5 over 2. Switching over to the other line, again, I have my blue pen now. Those 2 dots, it doesn't matter which one you start at, but again, please make sure that you're moving up or down first. So I'm going to start at this one on the left here, and we're going to go down and then to the right. So now when I count, this time I have to go down 1, 2, 3, 4. So that you're moving down, y's are negative, and then to the right, 1, 2, that's a positive 2, and negative 4 divided by 2 is a negative 2. So the slope of your second line is going to be a negative 2. If I look back over here, again, parallel lines have to have the same slope, therefore these are not parallel. I'll use the symbol of parallel just to be lazy. Okay, and y, they do not have the same slope. So for our second example, we're going to do the same thing, but this time we want to know if the lines are perpendicular. So again, perpendicular lines are going to have negative reciprocal slopes. Doesn't matter which one I start with. I'm going to start with that M1 again. M1, I'll highlight the 2 points on there in red. And again, let's count how we're going to have to move to get to one point to the other. So here I'm going to have to go down and then over. Okay, and be really careful when you're counting here. So I'm going to go down 1. So the change in y is going to be a negative 1. Again, change in y always has to come on top. And then I'm going to go to the right, 1, 2, 3, 4, 5, 6. And as you move to the right, x's are positive, so 6 is going to go on the bottom. Change in y always has to be on the top for slope. So the slope of that first line is negative 1 over 6. For M2, I have this point right here and this one here. Again, it doesn't matter which one I start at. I tend to start at that one on the left-hand side. So let me start at the one that's up here. I'm going to X right there. So I'll start there. Again, I have to go up or down first. So this time I'm going to have to go down and then left. So now for the slope of 2, let's count. I'm going to have to go 1, 2, 3, 4, 5, 6. So I went down 6. So y's are negative as you go down. And then I went to the left 1, and x's are negative as you go to the left. So the slope of line 2 is going to be negative 6 over negative 1, or negative 6 divided by a negative 1 is a positive 6. So now we need to decide, are they perpendicular? If they're perpendicular, the slopes have to be negative reciprocals. So the negative part, 1 has to be negative, 1 has to be positive. I have a negative 1/6 and a positive 6. I have that part. And then I need to see if I flip this, would I end up getting this? And the answer is yes. So yes, they are perpendicular. And that is because they have negative reciprocal slopes. So we want to write the equation of a line in number 3 that is parallel to y equals 2x plus 1 and is going through the point 2, negative 1. Okay, so if it's parallel to this given line, they're telling you that so that you can figure out what the slope is. So to write the equation of any line, you always need the slope. So that's where we're going to get the slope from. So the slope of this given line is 2. And that means that the slope of a line that's parallel to that is also going to be 2 because, again, parallel lines have equal slopes. So right now I have the slope, and over here I have a point. So again, instead of making myself more work, I could do slope-intercept form, but then I'm going to first have to solve for b and then plug back in to write the equation. But since I have the slope and a point, I'm just going to do point-slope form right away. So I'm going to do y minus y1 equals m times x minus x1. Okay, and this ordered pair is going to become x1, y1. So I'm going to have y minus from the formula, and y1 is negative 1. So I'm going to have y minus negative 1 on the left, and I'm going to take out m, not write it again, and m is 2. And then I'm going to bring down that x, a minus from the formula, and x2 is also 2. So the only way that I can clean this up again is on this left-hand side. Let's get rid of that double negative. Double negative is positive. So you're going to have y plus 1 equals 2 times x minus 2. And that's going to be your final answer for that one. Okay, for number 4, we want to write the equation of the line that's perpendicular to 3y minus 2x equals 1 and going through the point 4, 8. So again, they're giving me this first equation here so that I can figure out what the slope is, because that's the piece of information that I'm missing. So the first thing that I need to do is I need to figure out what the slope of this line is. It is not negative 2. Okay, I can't pull off the negative 2 right now because that is not in slope-intercept form. The y is not by itself. So let me bring down that. Oh, sorry. I don't know why this is coming in on me like that. Okay, so I just rewrote that equation, and now my goal is to solve for y. I want to get this y by itself. So the first thing I'm going to do is add 2x to both sides. Those will cancel, leaving me with 3y on the left, and on the right, again, I want this in y equals mx plus b form. So I want that mx term to come first. So I want this positive 2x to come first, and now this is a positive 1, so we're going to write plus 1. Okay, and then to get y by itself, the opposite of multiplying by 3 is to divide by 3. Those 3's will cancel, so I'll be left with y on the left. Now, on the right, you have to divide each piece by 3. And again, whenever something is not divisible, you just leave it in fraction form. So 2 is not divisible by 3, so we're going to leave that as 2/3 x. And 1 is also not divisible by 3, so I'll just leave that as 1/3. It does not matter that you have fractions here. Okay? The only reason that you need this equation is to pull off the slope. So the slope of this given line is now 2/3. Okay, but that is not going to be the slope of my new line. The slope of my new line, they're asking me to write the equation of a line that's perpendicular to that. So now I need the slope of a line that's perpendicular to 2/3. So I'm going to flip that. So if I flip the 2/3, it'll become 3/2. And again, if the first one's positive, that means the second one's going to be negative. So the slope of the line that I'm writing is going to be -3/2. And again, instead of making myself more work, I now have the slope and a point, so we'll use point slope again. So y minus y1 equals m times x minus x1. Or y minus 8 equals negative 3/2 times x minus 4. And that is your answer. Okay, and then our last question. Are the lines 3x minus 2y equals 5 and 6x equals negative 4y plus 2 parallel, perpendicular, or neither? Hey, again, the second you see parallel or perpendicular, you should be thinking, I need to find the slopes of these two lines. So just like in that last example, I can't pull off the slope in either one of my equations right now because they're not in slope-intercept form. So let me pull down that 3x minus 2y equals 5. Okay, and let's get y by itself here. So the first thing I'm going to do is get rid of this positive 3x. The opposite of a positive 3x is a negative 3x. Those will cancel. Just be careful. Please make sure that you're always taking the sign that's in front of that number. So you're going to be left with a negative 2y on the left. And on the right, again, I want this x term to come first. So it's going to be negative 3x. And on top here, that's a positive 5. So that's going to be negative 3x plus 5. Last step to get y by itself, the opposite of multiplying by negative 2 is to divide by negative 2. The negative 2's will cancel on the left, leaving me with y. And on the right, again, I'm going to need to divide each piece by a negative 2. So a negative 3 divided by a negative 2, you cannot divide, so I'm going to leave that in fraction form, but I am going to clean that up because a negative divided by a negative is a positive. So that's going to be 3/2 x. A negative divided by a positive, I'm looking at the positive 5 now. Positive 5 divided by a negative 2, that's going to be a negative. And again, 5 is not divisible by 2, so I'm going to leave that in fraction form. And now I can pull off the slope of that line. My y is all by itself, which means the slope of this line is the coefficient of x, which is going to be 3/2. So there's the slope of my first line. So now I'm going to go back and find the slope of my second line, and just be careful because I feel like they're trying to, let's see if I write it correctly, copy it correctly. They're trying to trick you here. Okay, you want to get y by itself, not x. So you can't just divide both sides by 6 and be done with it. Okay, so if I want to get that y by itself, the first thing I'm going to have to do is get rid of that positive 2 that's to the right of it. So I'm going to subtract 2 from both sides. Okay, those will cancel on the right. On the left, 6x and minus 2 are not like terms. You can't actually subtract them, so we're just going to leave it as 6x minus 2. And on the right, I'm going to have negative 4y. Okay, and now the last step to get y by itself, the opposite of multiplying by a negative 4 is to divide by a negative 4. So again, we're dividing each piece by a negative 4. So I have 6x divided by a negative 4. Again, 6 is not divisible by negative 4, so I'm going to leave it as 6 over negative 4 and tack on my x. And then negative 2 divided by a negative 4, a negative divided by a negative is a positive, and I can't divide 2 by 4, so I'm going to leave it as 2 over 4. And on the right, the negative 4's will cancel, leaving me with y. Y is all by itself. If for some reason you don't like that y on the right-hand side, put it on the left-hand side. It is absolutely no different. Okay, and now that's in y equals mx plus b form, and now I can pull off the slope. The slope of this line is going to be negative 6 over 4. So I'm just going to reduce that negative 6 over 4 and see what happens. So 2 goes into 6 3 times, so I'm going to have a negative 3 on the top, and 2 goes into 4 twice. So now I need to decide, are they parallel, perpendicular, or neither? Okay, so parallel lines have equal slopes. So I have 3 over 2 and negative 3 over 2. A negative number can never equal a positive number. They're not parallel. Perpendicular lines have negative reciprocal slopes. That means one has to be negative and one has to be positive. I do have that. I have a positive 3 over 2 and a negative 3 over 2. So I do have the negative part, but now are they the flip of each other? I have 3 over 2. The flip of that would mean that I'd have to have 2 over 3, and I don't have that either, so they are not perpendicular. So in this case, they are neither. Okay, they don't have equal slopes and they don't have negative reciprocal slopes.